Hey everybody, this is Larry. This is day 8 of the Leetcode Daily Challenge. There's also a weekly premium question that we'll do afterwards. So definitely check that out, especially if you have premium. If not, also just check it out so that, why not? I don't know. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, Jump Game 2, which I guess I've done. I've done a lot of jump games. But yeah, speaking of jumping, I have been for the two people who asked, which maybe whatever. Yesterday I did my squats again. I've been kind of moving up slowly, doing 260 k. No, not kg, pound, which is I don't know how much is that in kg. Yeah, like about 115 kg, kilograms on back squats. Did 4 sets of 5 or something. So I'm kind of but I'm probably gonna take a break. I think I'm really tired physically. I feel like looking at or just recollecting on my recent videos. I feel like I complained about being tired a lot. So I feel like I need to take some rest days. So that's basically what I'm gonna do. So yeah, let me know about your jump fitness goals and plans in the comments, or just in the Discord. We have a fitness channel. I'm not trying to be a fitness influencer, but but just curious, I think we obviously talk about Leetcode and a lot about computer science and maths and all this stuff, but definitely everything feeds into each other. Having a strong, or maybe you don't have to be strong, but like just having a reasonable, healthy physical base will kind of allow you to grind on the harder stuff when you need to, right? So yeah, anyway, no more ranting from an old Larry. You could just be like, get off my lawn or something. Old man shouting at clouds. But anyway, today's problem is 45 jump game 2. So you're given a 0 index array of nums of length and you're initially positioned at num 0. Okay. I feel like I did this even recently, but maybe that's another jump game. There's so many jump games or whatever. Anyway, so maximum length of a forward jump from index I. In other words, you can jump to. Okay. I feel like we really did this one recently or something. But yeah, so the naive thing to do, or maybe not naive. I mean, obviously you can. The more naive thing is to simulate it, but or like brute force, try everything. But yeah, the idea for this problem, I believe, will be dynamic programming. And there's a naive way to do the dynamic programming, and then there's kind of like a sort of a trick. I don't know if this is whatever, but yeah, and there are a couple of ways to do that as well. But yeah, let's think about the dynamic. So the really naive dynamic programming, right, would be something like this. And apologies if I think you probably do not need, to be frank, you probably do not need a strong dynamic programming thing to solve this problem particularly, because I feel like I have a sense of the answer and I'm just kind of going in another direction a little bit. But definitely you should still have a strong, or not, or at least like a reasonable understanding of dynamic programming for other Leetcode interviews or Leetcode problems and interviews and stuff like this. So I still urge you to kind of, if you don't understand what I'm doing on the next part, definitely practice a little bit more or ask some questions on the comments or Discord or this other stuff, right? So yeah, so here times maybe n+1, maybe, I don't know, maybe I always do n+1 just in case, right? So then the naive thing would be given, something like this, and then dp of I plus j is equal to max of dp I plus j, oops, or dpi, right? Because this represents, and maybe starting at 1 and also inclusive properly. And then you also have to make, double check that I plus j is less than n. Let's just do that here then, right? Right. So, this is basically a very simple to write dynamic programming, bottoms up in this case. I'm not going to go over it that deeply, which is why, I kind of had that caveat earlier, mostly because this is wouldn't say it's wrong. It's correct, except for if you look at constraints, it's going to be too slow. It is going to be 10 to the 7. What's 10 to the 7? 10 million? I guess 10 million in some contexts can be fast enough. But in Python on Leetcode, probably not what you're aiming for. Yeah, so in this context, it is not, right? So then the question is, yeah, the question is, how do you think about this, right? And this is a little bit wrong, actually. I forgot to do like +1 and stuff like this. Actually, I think that fixes it. So, sorry, my bad. I thought I had infinity, and it's in max or minimum number of jumps, so I kind of messed up some stuff here. But the recurrence is mostly the same, except for Larry is an idiot. But I'm getting my rest, so hopefully I'm coming back a little bit. All right, something like this, right? So I think this is actually right, give or take. But again, it's gonna be the complexity is what I'm focusing on. Is it's gonna be too slow, right? So then the idea here is actually gonna be a little bit tricky, really, right? Because then here, the vision, for me, a lot of what I talk about and in these things, at least this is the way that I solve these problems. Maybe, I don't know, maybe you don't need to, but the way that I think about these problems is this idea. Is trying to figure out a way to visualize it in a way that I can manipulate things in my head. Sometimes, I have a notepad, so I'm a little bit messy today, so my notepad is under a lot of stuff. I'm just gonna try to find my pen. Okay. Let me draw it out right now, right? Hang on, friends. My cable's a little entwined. But yeah, but basically the idea here, I think, if you look at the recurrence, which I had up, right? Basically the idea is that, okay. So basically, let's say you have, without a loss of generality, or maybe just a different way of representing it, maybe, is just that, we have, a lot of these cells, right? Or things on the number line or whatever, right? It doesn't, same idea. And here you can maybe say you can go up to here. Here you can go up to here. I'm just drawing random lines, right? And then here you're trying to find the minimum number of steps from the first point to the last point. And as we said, there's a dynamic programming formulation, because basically this is just shortest path in the DAG, right? You see the arrows, you see the DAG, and so forth. And of course, this isn't the full graph, because in a way, if let me change the color a little bit. If we're talking about, for example, this one that we drew, right? That is actually not the only edge, right? Because from here, it also implies this one. I'm just drawing a little bit lazily for the other ones. And here, right? But the key observation, or at least the, thing is that you are able to go to all the ones up to the last point, right? And then the idea for me is try to think, and I don't know if I'm going to explain this quite well, because I think this takes me a little bit, like when I was trying to figure out this particular problem, took a while to kind of really visualize this correctly. But the idea here is that maybe instead of say, this point is at 0, right? Maybe another way to think about it is that, as we're going from left to right, as we're going to left to right, as again, this goes to here, right? Oh, what the? What happened there? Maybe I was too close to the thing. Hang on. Yeah, as again, we go from here to here and everything in between, right? But another way to think about it for me, and one technique that I do a lot, at least in my head, in terms of these 1D, one timeline problems, is that instead, one way that I could think about it is maybe I could enqueue a 1 here at this point, and everything in between, right? So everything in between here is at most, except for the 0, because that's where you are. Everything here is at most 1, right? Because if it's more than one, then you don't have to update it, etc., right? And then from then on, you can maybe, in a way, keep track. So here, now you can update all these things without, oh, sorry, you can have a representation of this update without updating all the individual items, right? Because if you really think about it, as a result of this, then this is going to be a monotonically increasing going from left to right, right? Because, for example, there's no way that the shortest path to here would be 2, because by definition, you're updating as 1, right? And let's say we use this one, right? Let me use another color. So we have this graph here, or this edge here. That means that there's no way that this is going to be 3, because you know that coming from 1 to this 3, this space is going to be 2, right? So then that means everything up to here is 2. So using this idea of, in my mind, maybe you could say that put in an event, but it's also just like a way of compressing a way of saying that a way of basically saying that everything, represent everything in between is going to be 1, right? So that's basically the idea. There probably is a really, I know, I kind of know the easier way of doing it, but I think from this, yeah, I think we can, start implementing on this. Okay. So, okay, yeah. So I think one thing that I didn't really put, maybe I did, right, is that everything beyond that point is a 1, right? So in a way, you can kind of do I don't do this because I don't think this makes sense that often, but almost kind of like a level first search, right? I think some people do it in my Discord, and some other people just do. But I think that's for this particular problem, it is a way to visualize it in that way, right? Almost like a breadth first search, even, right? Where you go to those things, and then now, basically, yeah, all the numbers up to a certain number is going to step 1, right? So okay, I know there's another way of writing this, but I'm going to write it using that way, and then maybe that'll be a little bit, fun, I guess. So okay, so let's say distance is equal to 0, and then I is equal to 0, right? Or distance being step, I suppose. But yeah, while I is less than n, right? How do we say it? So the farthest that we can go here from this particular spot is going to be num sub I plus I, right? Yeah. So this is the farthest index that it can go. Yeah. And then the current distance, how do I write it in a good way? Basically, yeah, I mean, I think the level thing is a little bit better. So maybe I would do it think about it that way. So how would I think about it that way, right? So then here, maybe I would do something like, yeah, so while I is less than n, or maybe like while, yeah, okay, so then basically, this is the farthest that this cell can go, and then, yeah, maybe I just keep it in a way then. Okay, so yeah, so farthest, so farthest of distance plus 1 or something like this. So the farthest is equal to yeah, if, or the farthest you can go is 0, I suppose. right? And then basically, yeah, right? Maybe something like while distance is less than length of the farthest or something like this, right? So then now we do something like for I in range of um from maybe just I is less than the farthest of distance, something like this, right? So then now farthest of distance plus 1 is equal to the max, the farthest you can go of all the ones, right? Something like that, maybe, right? And then increment by 1. Um, Something's a little bit off. Hang on. All right, so 0. I think this is equal to maybe. Yeah. Right. All right. Let's see what this returns me. I think I'm confusing myself a little bit as well, doing it this way. Oh yeah, I forgot that I have to do if I if farthest the last one is less than n, then we append a 0 or something. Maybe something like that. I'm definitely writing this in a weird way, but I hope that this makes sense at least logically, even though my code is struggling a little bit. So okay, so it goes 0 to 2, okay, and then it goes to 8, and then this is oh. Well, this doesn't add anymore, but it was trying to process the I. I think I need I is less than n as well. Yeah, okay, that's fine. Maybe, maybe not. I don't know. Maybe I misunderstood this though. Jump from 0. So yeah, from 0 we go to the 2, so 0 and 2, and then 4 we should be already be done. So why are we not done? Oh, because we haven't processed all of them. Oh, also because I just returned. Yeah, I'm just being dumb. Though this 4 means that it is. I think this is just. I'm trying to think whether this makes sense, but I think this is just return distance. Then I think that's actually maybe cleaner than. Oh well, I think I have to do otherwise. Further start append 0. Oops. All right, that's not good. Oh, this is distant -1 because we have to adjust for this one because last one it passed. Maybe I could have done it here, and then. But all right, let's give it a submit. Hopefully, I didn't miss an edge case. Oh no, is there like a 0 thing and then it just never? Is there like a -1 answer? Maybe I'm going to time out. In that case, yeah. Oh, this isn't even a 0 answer. It's just it doesn't have to go anywhere. Can we? Okay, yeah, you can always reach it, but here you already started from there. Why does this end? So this I over n. Oh, I see. No, but so this never ends. Distance +1 increments. But then the 0 should already be bigger than n. Oh no, n is 1. And then this never updates. Because this never happens, then the last one is 0. there should be n minus 1 because this is the farthest that we reach. So I think that's just what that is. Oh no. And then maybe we don't need the distance minus 1. Maybe that's where I messed up. Maybe I cheated the wrong way and kind of hand waved it. All right, let's give it another spin. All right, this time I'm good. Wow, apparently I get this one wrong a lot. But yeah, as you can see, this is going to be linear time, linear space because I have furthest. But keeping in mind that, you know, furthest, we actually only need the last two things. So you can actually reduce this to constant space if you like. And in fact, I think the way that people like to write this is like a weird for loop, right? So yeah. Oh, actually, I did memorization last time. Yeah, I think this is the way that I was kind of thinking about, but I think that's like a really hard to understand way. I think the way that I explained it today is a little bit cleaner, minus some silliness around typos and stuff like that. And like I said, you don't really need. Yeah, maybe the way that I should have done is furthest is equal to 0. If furthest we return distance. Otherwise, new furthest is equal to 0. And then I think maybe this is a little bit clearer. I think the distance stuff actually made it a little bit more confusing, which is my fault. Oops. But I wasn't. But I think these things with respect to with respect to optimizations, I think it's okay. It's I forgot to update. I mean, I think these things are okay to not, you know, optimize on the first go and just kind of make sure you have the understanding. Okay, it's going to time out because I forgot to update it, and then we'll run it again afterwards, and then we'll hopefully submit again for the constant thing. So that's the constant update that I was talking about. And even though the way that is that not right? Is there another infinite loop? But yeah. You know, this is why you get something right first and then you optimize it. But as you can kind of see from what I was talking about, even though you look at this and you may not think dynamic programming, it is definitely. Is it not going to just give me the case? Oh, I guess this is from my cases, right? Is it this one? No, it should be, that one should be okay. But yeah, you can see kind of where I built off the dynamic programming structure and thinking to kind of come up with this solution. Yeah. Why is it so slow? I mean, am I missing a thing? I+1, we max. This one goes only I times, so the only thing is if. So this doesn't break, but let's see. Okay. Oh, whoops. Oh. Why? Huh. Wow. I misspelled it consistently in like so many places. Oh, jeez. And then I just confused myself. That's why. Okay. I mean, I was worried. I was like, I don't get it. Other than the typo, I don't get it. Right. So okay. So that. I don't feel so bad. Other than that, I've been doing a lot of these kind of mistakes lately. So this is one good thing of a type saved language. But yeah, you can see that this is, you know, constant time. Oh, sorry, constant space. What am I saying? Linear time, constant space. We have to look at each number in the array at least once. I guess maybe not technically in the best case. For example, if the first numbers jump to the last one, but in most or in the worst case, say it's going to be linear time because you have to look at every cell one. You can imagine all of it. It's a one, and then in space here you can see it's just a bunch of variables, so it's going to be a constant space. It's a long video. Hopefully, if you struggled, it helped. Otherwise, yeah, and you could see how Larry kind of stumbles around it. But yeah, I am going to do the premium problem afterwards, so stay tuned. Hit the subscribe button, hit the like button, and give me some love. And that's all I have for this particular problem. So yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.